about thermochemistry. Thermochemistry is the study of energy in chemistry. And so, two definitions. Energy is the capacity to do work or supply heat. Thermochemistry is a study of energy in chemical reactions and physical transformations. Another term we need to know is specific heat. Specific heat is the amount of heat required to increase the temperature of 1 gram of a substance 1 degree Celsius. We'll take a moment to talk about units. Energy is expressed in joules or calories, and temperature is in Celsius or Kelvin. We can also use Fahrenheit, but in science we use Celsius and Kelvin. Remember, heat is a form of energy. Two terms a lot of people misuse are heat and temperature. Heat and temperature are not the same thing. Heat is the total energy of molecular motion in a substance. It depends on the speed of the particles, the number of particles, and the type of particles. Temperature, however, is the average kinetic energy of molecular motion. It does not depend on the size or the type of the particle. So, for example, a cup of hot water and a bathtub full of hot water could be the same temperature but have different amounts of heat because there's a different number of particles of water in a small cup versus a great big bathtub. Two terms you've heard a lot in your science careers are endothermic and exothermic. We do want to make sure we understand the difference. Endothermic is the addition of heat to a system. The temperature of the system increases, and therefore the motion of the particles of the system increases. Whereas exothermic is the removal of heat from the system, and so the temperature of the system decreases, and the motion of the particles of the system decreases. So here's a question I want you to think about and be ready to answer tomorrow. Why are most combustion reactions exothermic? Why? They feel hot, right? And I just told you that heat was being removed from the system. So why is it that a combustion reaction is exothermic, yet they feel hot? Be able to explain that to me tomorrow. Alright, so calorimetry is the process we use to measure heat lost or absorbed. Okay? We cannot measure heat directly. We can measure temperature changes using a thermometer, but heat we cannot we don't have a heatometer, if you will. So we use this idea of specific heat. Specific heat, again, is the amount of heat required to increase 1 gram of a substance 1 degree Celsius. And so in class today, you've learned about this equation. You derived this equation where heat is equal to the mass times the specific heat times the change in temperature. That is Q equals M for mass, C for specific heat, and delta T for the change in temperature. And that delta T we find by doing the final temperature minus the initial temperature. And this equation is in your reference packet on your equations page, so you do not have to memorize it. But you probably will as much as you're going to use it. So, if we know the mass and the specific heat of a compound or substance, and you measure the change in temperature, you can calculate the change in the heat. So when we find Q, right, it's either going to be positive or negative, and that's going to come out of the fact that the delta T is either positive or negative. So if you increase your temperature of the system, so we talked about a moment ago, Q is positive, and therefore that reaction or situation is endothermic. Whereas if you have a decrease in temperature, your delta T is negative, your Q will be negative, and therefore that is exothermic. So a positive Q is endothermic and negative Q is exothermic. Positive and negative simply tell the direction not the magnitude, just the direction of the heat. Is it going in or is it going out? You can think about it like your checkbook, your checking account. You put money in, you add to your checking account. If you withdraw money, you take it out, you subtract it, so it's negative. Let's look at example problem 1 in your packet. It says, if 25 grams of liquid water is heated from 10 degrees Celsius to 25 degrees Celsius, what is the change in heat of the water in joules? The specific heat of water is 4.18 joules per gram degree Celsius. So let's divide out what we have here. Let's plan it out. We know we need Q, M, C, and delta T. It was their equation we just learned. Q represents the amount of heat. Well, the question says, what is the heat change? And so that's what we don't know. It's how much heat. What is the mass of our water? 25 grams. And it tells us C, the specific heat, is 4.18 joules per gram degree Celsius. And then it tells us our temperature change from 10 to 25. Now we just learned that delta T is final temperature minus initial temperature. And that is important to make sure that your amount of heat, that your direction of heat is the correct direction. Is it in or is it out? And so then we plug those numbers into our equation. Q equals M, C, and then delta T is positive 15. And we get 1600 joules. You actually get 1575 or something like that. But to round to our significant figures, we want to use the information that we have in our problem. Always your smallest number when you're multiplying. Okay. Alright, next I want you to try the practice problem on the next page. I have the answer here to see if you can get it. If you do not get the right answer, then after you hit pause and you come up with the incorrect answer, go ahead and hit play again, and then I'll show you how to solve the problem. Alright, so let's look at the practice problem together. If you place 15 grams of ice in a cup and is heated from negative 25 degrees Celsius to negative 5 degrees Celsius, what is the heat change of the water in joules? And the specific heat of ice is 2.1 joules per gram degree Celsius. So what is our mass? It says it's 15 grams. Our specific heat, it says is 2.1 joules per gram degree Celsius. And delta T, again, is the final temperature, which is negative 5, minus the initial temperature, which is negative 25. So minus a negative, remember, gives us plus positive. And so our change in temperature is a positive 20 degrees. And again, we're looking for the heat, how much heat. So Q equals M, C, delta T. And so we multiply all those together, and we should get 630 joules. Alright, so next you'll need to watch part 2, which will be in the next video.